The next factor I'm going to talk about now is the concentration of the reactants and how the concentration of the reactants affects the rate of a reaction. Now I've written here in my notes, concentration increases, rate increases. So when one goes up, typically the other one goes up also. So as you increase the concentration of your reactants, the rate of the reaction also increases. And now, how does that happen? Well, increasing the concentration of molecules increases the frequency of collisions and thus the rate of reaction. So if I were to draw two beakers here, so this is number 2 here. If I were to draw two beakers and I were to put my particles into each of the beakers, but I only put a few, small few, into one beaker, but in the second beaker I packed them all in, loads and loads of particles in. So here you see low concentration of particles, and here you see a high concentration of particles. Right? There, low concentration means there's very few particles. High concentration means there's a lot of particles. Now, if you have a lot of particles, the particles can bump into each other more often. And that stands to make sense. If you have a lot of particles within the small one area, there's a greater chance of bumping into each other, or in terms of chemistry, collisions. If you have very few particles in the same amount of area, there's going to be fewer chances for collisions. So we're going to put in here a few collisions. And here we'll just put in more collisions. Okay. If there's more collisions, that's going to speed up the rate of reaction or make it a lot faster, whereas here it's going to be a lot slower. Eventually the particles will bump into each other and eventually the reaction will occur, but it's just going to be a lot more slower.